Let's go through LeetCode 493, reverse pairs. For this question, he gave us an integer array nums, and let's find how many reverse pairs. For this question, it defines a reverse pair is that for any index I and j, I is smaller than j, but nums I is greater than 2 multiplied by nums j. So intuitively, we can think about using the brute force way to iterate I for each I and for each j has two for loop to see if they are reverse pairs and add to our result. But doing like that, this kind of range will be O n square time complexity will be TRE, right? So we should have beta time complexity at least to be n log n time complexity, right? So n log n, what we're thinking about is that for example, binary search, for example, merge sort or quick sort, right? And sorting. For this question, we are using the merge sort to do the problem, right? The reason is that and we know the feature of the merge sort, right? So it divided those kind of arrays into different parts and divided by different parts, right? Then merge this and merge this, right? Merge to this part. So when this part and this part are merged, this part are already in ascending order. This part are also in ascending order, right? So if we have an I and a J, we find for an index I, where the nums I is greater than 2 multiplied by nums J. Then from this kind of middle M plus 1, right, to J, all of this part and I can forms the reverse pair, right? So during our merge, we can see how many reverse pairs for this kind of part, right? And after merge, it's already increased. So this part reverse pair we calculate for the comes for the total result. Then what we do is that we merge, for example, this part and this part, right? So the same thing, ij, right? So if we find a reverse pair, because that is already in this part is already sorted in ascending. This part already sorted in ascending order, right? So during the merge, right, we can count because it has a monotonic increasing property. This has a monotonic increasing property. So we can do count before we merge, right? And for this count, the reverse pairs for this part and this part, that will be the ON time ON, right? So doing like this, the total time complexity will be n log n, right? So let's begin to write code for this. Actually, we'll have int n equals nums dot length. And we'll have which we know merge sort we need to have greater temporary, right? So that will be more efficient than in the merge part we create the temporary. So return merge sort. For this merge sort, we are going to have integer counts as a return, right? And 0 and minus 1, right? So private int merge sort. So we have nums and temp and int start and int end, right? So if start is greater equal to end, we just return 0, right? That is an exit condition. Then we divide conquer int sum equals to 0, right? Sum plus equal to merge sort. Merge sort nums. Let's have a mid, right? Mid equals start plus and minus start divided by 2. And temp start mid and also sum plus equal to merge sort nums temp mid plus one, right? Mid plus one and end. And then we'll have sum plus equal to merge, right? We need to merge it, nums and temp and start and mid and right. We need to write a merge function for it in merge. During this merge, it counts how many reverse pairs from this start to end. Nums int temp int start int mid int end, right? So here there is two things we need to avoid, right? So we need to here when we merge, right? We'll say this part is already in order. That this part is already in order. We have I pointer and j pointer, right? So if this nums I is greater greater than 2 multiplied by nums j, then move I pointer. So we need to write another while loop here or to count, right? So we cannot doing during the merge. I will show one of the mistake I did before, but let me write code for counting the sums here, right? Return sum. Okay. So int left equals start and the right equals mid plus one, right? So we'll have sum equals 0. So we'll write left smaller equal to mid and right smaller equal to end. Right? So I say if here the thing is that this num it can be out of the limit of integer max. So let's change this one to long type nums left smaller equal to 2L multiplied by nums right. In this case, we'll have left move left pointers, right? And also move the right pointers, right pointers. Here actually move the right pointers, let's see, because so we know we can either fix the left pointer or right pointer, right? So if and that means well, actually we fix the right pointer will be easier because now if we move the right, if we go to this else, that means that left is already greater than 2 multiplied by nums right. So everything from the left to mid will form the reverse pair with right? So we'll have sum plus equal to mid minus left plus 1. Then we should reset left equal to start and right equals minus mid plus 1, right? And we can have an int I equals start. So what do we need to here is the merge. While left smaller equal to mid and right smaller equal to end, right? So I say if nums left smaller equal to nums right. So I have temp I plus equals nums left plus, right? And also let's say else temp I plus equals nums right plus. At the beginning, when I write this code, right, because I think this kind of two while loops looks nasty here. So the first version I write is that if else if nums left smaller than 2 multiple by smaller equal to right? Multiple by something nums right and else. This is my first version and it's not correct. And I comment this part at the beginning, and that's not correct because this kind of 2-pointer moving criteria is that the left should be when it is smaller than 2 multiple by nums right, and here the left and right pointer, the moving criteria is compare left and right. So you cannot combine these two here, right? So you need to write another separately, to while loop separately, right? But of course you can use a for loop to write this, and but this will not add to our complexity, right? Because this is a 2-pointer, and this is the same complexity with here, right? So after this while loop, we'll say while we'll say if left is not end, right? While left smaller equal to mid, we'll have temp I plus plus equals nums left plus plus, right? And while right is smaller than end, right? Right is smaller equal to end. If right is not end, we'll have temp by plus plus equals nums right plus plus, right? After this, what we do is that we need to copy those kind of result from start to end to these nums, right? So what we do is for into k equals start, k small equal to end, k plus plus. We have nums k equals temp, k, right? So this is our solution. Yeah. Line 4. New. Anything else? 47. This one merge, we need to return sum, right? Return sum. Yeah. We can also convert this to Python code. So it will be similar, right? So we'll say we'll have a equals length nums, right? So we'll have temp because notice for merge sorts, we create temp outside will be more efficient, right? Then we return merge sort nums temp and 0 and -1, right? So this is main function. We need to define merge sort. So we should have nums as list int and also temp as list int, and we should have start as int and as int, and it returns an int, right? So we'll say if we start greater equal to end, we just return 0, right? And we are going to have mid equals start plus end divided by 2. And we'll have a sum equals 0, right? Sum plus equal to merge sort nums temp start mid sum plus equal to merge sort nums temp mid plus 1 and sum plus equal to merge nums temp start mid and return sum. Right? Let's define another function called merge. We should have nums as a list integer, temp as a list, right? And we should have start as int, mid as int, end as int, return int, right? So for this kind of thing is that we also have two while loop, right? So we should have left, right, and sum equals start, mid plus 1 and 0, right? So let's have while left small equal to mid and right smaller equal to end, right? So let's say if nums left smaller equal to 2 multiplied by nums right, then we need to move the left pointer and plus equal to else else we'll move right pointer, right? So right pointer plus equal to 1, right? And then we can have sum plus equal to mid minus left plus 1, right? Then we do the merge sort, right? Before we do the merge sort, we need to reset these values left, right. Let's have an I variable, right? Start mid plus 1, and I also to be start. So let's say y left smaller equal to mid and right is smaller equal to end, right? So we compare if nums left smaller equal to smaller equal to right nums right we'll have more we'll have temp I equals nums left, and we'll have I plus equal to 1 in the left plus equal to 1, right? Then else what we do is that temp I equals nums right, and we'll have I plus equal to 1 and right plus equal to 1, right? So this is and it's possible that left haven't finished, right? So we'll say while left smaller equal to mid, then we'll have temp I equals nums left, and we'll have I plus equal to 1 and left plus equal to 1, right? And also it's possible the right is not finished, right small equal to, and we'll have temp I equals nums right, and we'll have I plus equal to 1 and the right plus equal to 1, right? After these two while loop, we need to copy the temp array to this number array, right? For k in range start to end plus 1, right? And we'll have nums k equals temp. Okay. And for this kind of, it will need a return, right? So we need to return the sum. Yeah. So this will be the Python code. Okay.